Hello friends, so in this video we're going to be studying the conjugates of surds. Later on in the video we're going to also be studying the rationalization of surds or the division of surds. Now we begin with the conjugates of surds. Now we said in the previous videos that surds of the form p plus root q, p plus root q, and surds of the form root p plus root q plus root q. We said that these surds are called compound surds. Compound surds. How true? How true? These are called compound surds. Now, compound surds always have related surds which are called conjugates. So compound surds always have related surds which are called the conjugate. For example, p plus root q, it has a related surd which is called the conjugate. While in this first part, p plus q, we have a positive sign there, the conjugate would have a negative sign. This will be p minus the root of q. How true? How true? The same thing applies, right? So for root p now plus root q, the conjugate of this surd would be root p minus root q. How true? Very true. So in taking classic examples now, we can have root 2 minus root 5. Root 2 minus root 5. The conjugate of this surd would be root 2 plus root 5. How true? So is this, the values remain the same, right? But the signs changes. Also, if we have 4 root 3 minus 6 root 2, the same rule applies, right? The conjugate of this surd would be 4 root 3. Now the sign changes to plus 6 root 2. How true? How true? Very true, very true. These are what we have when we attempt to find the conjugate of surds. Now we have to use this knowledge of conjugates to be able to solve questions that relates to the rationalization of surds. So now when we are told to rationalize surds, we need to apply the knowledge we have gotten from the conjugates of surds in solving such questions. Now let's go straight to the rationalization of surds. Now, rationalization or division of surds. Now, to rationalize or divide surds, we are attempting to reduce these surds to simpler but equivalent forms, right? And in order to do that, we are making the denominator a whole number. For example, now, suppose we have surds of the form 1 over p plus root q, 1 over p plus root q, or surds of the form 1 over root p plus root q, or even surds of the form a plus root b all over root p plus root q plus root q. Now, in order to rationalize these surds, what we do is that we multiply both the numerator and the denominator by the conjugate of the denominator. So we multiply both the numerator and the denominator by the conjugate of the denominator. So for this first case now, the conjugate of p plus root q would be p minus root q. So we multiply this denominator by its conjugates. So we also multiply the numerator by the conjugate of the denominator. Let's write that q properly. By the conjugate of the denominator. How true? Very true. For the second case now, the same rules apply. We multiply both the numerator and the denominator by the conjugate of the denominator. So Here we have root p plus root q. So we multiply that by root p minus root q. This would be the conjugate of root p plus root q. The same thing happens at the numerator. We multiply it by the conjugate of the denominator, root p minus root q. This is what we have in this form. How true, how true. So in the aftermath, we can extend the division line, and we can also do that here. Now, the same thing applies for this third case now. For this third case, we multiply both the numerator and the denominator by the conjugate of the denominator. So our denominator here now is root p plus root q. So we multiply that by root p minus root q. The conjugate will take a negative sign. The same thing applies here. At the numerator, we multiply by the conjugate of the denominator minus root q. How true, how true. Very true. This is what we're going to have in these cases, right? So we can extend the line, the division line, and this is what we have in these cases, right? Let's take some classic examples that will help us understand the concept better. Here's a good question, and we could be told to rationalize this question, right? So in doing this, the denominator now is root 2 minus root 3. So we have to find the conjugate, right? So the conjugate now would be root 2 plus root 3. So we have to change the negative sign to a positive sign. So we use that to also multiply the numerator, and this gives us root 2 plus root 3. The same rules apply. How true, how true. So in doing that, we can open up the brackets now. At the numerator, root 2 times root 2 now gives us root 4. The root of 4. Root 2 times positive root 3 gives us plus root 6 plus root 6. Now, root 3 now times root 2 gives us plus root 6. Also, root 3 times root 3 gives us root 9. Root 9. How true. Now, at the denominator now, notice now we have a difference of 2 squared there. We can choose to open up the bracket the same way we have opened this up now, but to simplify our work and to make our lives easier now, we can apply the rules of difference of 2 squared. Notice now that if we have a minus b multiplied by a plus b, recall that we can simply use the difference of 2 squared to evaluate this. We can simply evaluate this using the difference of 2 squares. So this gives us a squared minus b squared. This would be a simpler way to open up two brackets that have this form, right? They have similar variables and they have different signs. So we use difference of 2 squares. So here we have root 2 all squared minus root 3 all squared. So we apply the laws there and our answer comes out. So we can evaluate this in this form. At the numerator now we have root 4, and root 4 gives us 2. The root of 6 still remains the root of 6, but now notice now that we have root 6 plus root 6, right? So root 6 plus root 6 gives us 2 root 6, 2 root 6. Now here we have root 9, right? The root of 9 gives us 3. How true, how true. At the denominator now, we have this square cancels this square root and we have 2. This square also cancels this square root and we have minus 3. How true, very true. So we collect like terms and we have 2 plus 3 plus 2 root 6 plus 2 root 6 divided by, now 2 minus 3 gives us minus 1. So in the aftermath, this gives us 5. 2 plus 3 gives us 5 there, plus 2 root 6 plus 2 root 6 all over minus 1. So notice now that this negative sign affects everything at the numerator, right? So this gives us minus 5 plus 2 root 6. So no need for us to write the 1 at the denominator anymore. So this gives us our final answer to be minus 5 minus 2 root 6. How true, how true. That's my time, guys. So in the next video, we're going to be looking at more questions on rationalization on surds. Then we move on to radical equations. Thank you so much. See you in the next video.